Hello. Let's go. Okay, let's go. Let's read this. And translation, Martian translation. So this is the second part of the video. I didn't know that stopped, so I continued a lot without noticing. And this will be the second part of the 5-hour series. Okay, now let's see applications of NLP. One of them is translation. So Martian translation is subfield, of course. This. So translation is translating the word into another language. So there are two methods. The first one is static Martian translation, and so a neural Martian translation. Enmity, good. As you can see, all right. Tex Corpora. I think Tex Corpora, I don't know what it is, but there are, yes, in the past, these were primary methods for machine translation. And yes, yes, and statistical. machine translation. This use statistical method and this use neural method in text corpora. All right. Okay, let's say you have English language. Text to text and speech to speech. I think it's similar. Skype translators. Skype is down right now. So the underlying principles that work in speech-to-speech translation system indeed is text-to-text translation system. So before the translation starts, the speech has to be converted into text using methods from automatic speech recognition. After that, you got this automatic speech, then machine translation, which we said use two kind of systems. All right, so we can. Cool. All right, so statistical machine translation or neural machine translation. After the translation, text-to-speech synthesis is used to produce speech from translated text. Therefore, the quality of the output does not only depend on the quality of MD component, but also the quality of ASR and TTS component. What is ASR? Which is here you got automatic speech recognition ASR and TTS component, which is text. I think text to text speech translation. So before translation start into text, use this. After this translation, TTS synthesis is to produce from translated text. Therefore, the quality of the output does not only depend on the quality of the emit component, but also the quality of SR, which makes speech-to-speech translation challenging. So whenever you have speech-to-speech, first you gotta convert speech into text, all right, using automatic speech recognition. I mean translation, recognition. So you convert into this. Then after this, text-to-speech synthesis is used to produce speech from translated text. Therefore, the quality of the output does not only depend on the quality of machine translation component, but also the quality of ASR and TTS components. Notice the two biggest challenges in MT are domain mismatch and under-resourced language. Yes, indeed. Under-resourced languages are like languages in the southern hemisphere. So globe. Maple, right? Okay, let's say mapper. Or let's say globe. What is it? I don't know what global mapper is. So Okay, this is the image of the globe. And there are some languages, mostly. This is the globe, right? Most languages. So this is hemisphere, right? Let's say is global south, global north. Is this Europe, England here, America and Canada here? Right? This language, these languages are highly resourced because English, French, Germany, right here, French here, Italy here, and Arab starting from here, Northern Africa and Middle East, Turkey, Russia, the whole this part of Uzbekistan, Ukraine, Belarus, and a lot of places, and also China. Chinese language is also well trained. So Japan here, Japan is here, and so these languages are highly resourced, which means a lot of training data existed and a lot of research is being done and a lot of data can be found. But some languages in Africa, they say because Africa is like 300 tribes, 3,000 tribes. But when it comes to in Europe, only 87 tribes. In Asia, from 500 to 1,000 tribes exist. So Africa is very big, right? Africa is very massive in terms of race. A lot of languages exist. Let alone in Ethiopia, there are 18 tribes and more than 70 languages exist in Ethiopia. So all of these languages didn't grow into the expected level of in terms of production of data, organized data, right? So global south languages are likely harder to translate from English to this language, right? For example, you want to translate English, let's say Amharic, to German. So what you do is you want to translate this Amharic to Germany. What you do is first translate Amharic into English and then the English part into Germany. Okay, this is how you do. And because there are not a lot of Amharic contents, even if for the same English content, the quality will be different when you translate it to Germany or Amharic, because German language is a lot of highly resourced. I'm not saying Amharic doesn't have a lot of resource, but Amharic have a lot of resources, but in physical space, in books. There are a lot of books written in Amharic language, but when it comes to digitally well-organized data, we got less than Germany. So the two factors are, the first one is empathy, because as you can see here, when you speak in English, there will be automatic speech recognition, and then this conversion change it into text, and then you got this text, and then again you'll convert it using empathy into another text, then you'll synthesize the speech. So here, the quality of speech will be determined by this empathy. So the two factors, the first one is empathy, the MT process. The second is low resourced language. So as time grow, all right, so yes, this is it. Domain mismatch means the word and sentence can have different translation based on the domain. Thus, it is important to use domain adaptation when developing. When we domain adaptation, it means, let's say, for example, I can clearly. So, for example, if I want to translate one document, so domain list, domain translation. This is sparse. Okay. So this is my document. This is my document, and I want to translate this. So domain. For example, Amharic contents. Most of Amharic contents on digitals are some of literature, like poem or politics, comments like from Facebook, and let's say maths or physics or like biology. You get like small amount of data contents in Amharic, but you can find a lot of in politics. So when it comes to translate domain specific data, let's say literature or science, it will vary according to how much according to the amount of data being reproduced before. So yeah, so this is different domains mismatch, and the word and sentence can be different translation. Yes, it is important to use your. For example, there are no bilingual available for sourcing target language. One approach is to bring under. So previously, so since we don't have corpus for original and target enmity, so you use pivot enmity. Yes, use pivot enmity. This is what I'm talking about here. Yes, chatbots or text. I've read this. Now let's move into named entity recognition. Okay, this is the third advantage. Okay. All right, let's see. Named entity recognition deals with the challenge of locating named entities in unstructured text. All right, so you have unstructured text. Structured, which means, what do you mean by unstructured text? You have unstructured text which means you don't. So what is the problem statement here? All right, the problem statement here is this is what it is. It's what it solves. All right, now unstructured text. And what you want to do is you want to change this Alright, entity, classifying entities in structured text. Okay, so what you're gonna do here, there can be such as names, location, named entities in unstructured texts. Entity recognition. What the hell is entity recognition? What is entity? First of all, I don't get entity. I know entity, but what the hell is gonna? What the hell? I don't know what entity is. Alright, so let's see what entity means. Entity recognition known as predefined colors such as people, organization, location. Okay, cool. I get it. Cool. You have a text, then you will classify it into entities. So entity recognition. Cool. Be a name, it could be a person, it can be a day, it can be a quantity, it could be currency. Oh, this is how you so challenge locating classifying entities into entity in unstructured data. So you want to look at this. Right, so those entities can be then assigned to categories, many more, and named entity recognition play an important role in understanding the content of a text. These have really understanding the content of the content of the texts. It really helps, especially for text analysis and data organization. Because yeah, I mean, like here, and this is like came here literally, and then all right. So now, okay, where am I? Good starting point for further analysis. The following figure shows an example of how entities can be identified from a sentence. On Monday afternoon, I will meet Paul at the library. So you just change it into location, data. These are like many more names. So this is for good understanding. I have placed an important text. So let's create. How we gonna do? Oh man, this is alright. So you can classify them into categories. Name like could be location, where, time, when, the expressions, organizations, quantities, and many more. Like basically can like change it into assign it to categories like this. So so names, patients, you have unstructured data, then like classify this the text, the data into this and more, so you can understand it very well. It helps you like first you organize it and like text analysis. And like for example, place an important role the content of a text, deal with locating and classifying entities in unstructured text. This is crazy. Yes, good. Now let's move on. Alright, is a good starting point for further analysis. Following shows, for example, Monday afternoon. Alright, let's query. On Monday afternoon, let's take an example. On Monday afternoon, I will meet Paul at the library. Okay. I will meet Paul at the library. Okay. On the Monday afternoon, I will meet Paul at the library. I will meet Paul at the library. Alright, I will meet Paul at the library. Then when you entity so you have this Monday, this is date, okay, this is time, and this is person, and who, this is also person, and this is location. Entities are different because entities is different from noun or like part of speech. Entities are kind of noun things, but also things. So expressions times date expression, this is date. Okay. So this date, time, person, location, it doesn't matter. I used in all domain where categorizing there is kind of advantages. For instance, ticket and categorized according to their topics. Tickets can then automatically be forwarded to specialists. Also, if data has to be anonymized due to previous regulation, can also didn't get this part. Okay. Okay, you may be asked, example, advantage. Okay. All right. All right. Okay. Cool. These are applications. Let me ask this. Oh, okay, let's use, oh no, I can use it. So this is advantage. This is advantage. Sorry, oh yeah. Cool. Advantage. Let's say your tickets. Just remember this instead of this. Remember this ticket. Analyze. Analyze. Analyzed. Other. So it can cost tickets to specialists accordingly. Customer support. Resume. Extract information. These are very cool projects. And the full notice here. Yes. You can read this or advantage. Now, the biggest challenge. Cool. So, what's the challenge? It requires massive amount of annotated data. What is a statistics method? I haven't put this into my definition board. So let's copy this. Alright. Where was oh, my. Here. Alright. Can we still read? Yes, we are. Okay, now entity, and let's read sentiment analysis. I will do one project on translation though. I will do translation. Okay, yes. Chatbot, sentiment analysis. Yo, brother. Let's create a space here. Oh no, oh no, no, no. Oh no, 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 no. Yo. Okay, sentiment analysis. Yeah, kind of detecting emotions, such as analyzing the author's mood on Twitter, like topic identification. Sentiment analysis deals with text classification. All right. Oh, couldn't have okay text classification, which means kind of mode. Yes, this is very important. Okay, this will be your question. This can be one question. What is the difference between? So I can ask you this question. What is the difference between text analysis and what topic ideation? So my question, never ask in this is must be a question. Now you answer it. No. And so object is topic focus on object. Yes. All right, this is the answer. What the hell? Oh Jesus! Sarcasm detection? Oh, it can be. Oh yeah. Using whoa, this is crazy. I will try to read. This is crazy. Tweet sarcasm detection using. When was it? In China? Jesus, this is crazy. All right. Sarcasm detection. Sarcasm. Okay, we will see this part. It's a golden blue. The challenge is sarcasm is challenge because Negation the challenge when trying to. Whoa! What was the challenge? Statement, statement, sentiment. Arrangement to sentiment, statement, sentiment. And with morphology of words by prefix such as this and then less to. Alright. Okay, multipolarity. Stopwatch. Multipolarity. Oh. Multipolarity. Polarity. Okay. Additional. Alright. Multipolarity. Okay. Text can be positive while others are negative. Oh, okay. Okay, some part is positive. Given the sentence, the display of my phone is for the is display the dimensionals for the topic. Issue will be split sentence support for positive. Okay, so you split it apart. Right. Sarcasm. And now solution will be related to two parts. Solution for this. Alright. Solution for this is two part. Cool. How cool it is. Therefore, a better approach to tackle this issue will be spacing. Okay. Alright, sentiment analysis, we looked into it. And now this is to text summarization. Text rank algorithm. Okay. Alright, so let's read. Before reading, okay, for the next part, we're gonna let's do the NLP. What is the natural language processing? Compare goal of what is the primary goal of NLP in computer interaction? To make interaction more natural. Three, so the Swiss are yes. The speaker part, speech, then the understanding part, understand, then the generating part, so language generation. When did NLP become technical? What was the initial motivation? The initial motivation was in 1950s, and the initial motivation was due to Russian and Soviet Union. What was the 1964 was the automatic advisory language advisory GIMP lessons, yeah. What does this lead to regain? Yo, there are three things. The first is more slow, man. I remember more slow. I read more slow, but that law is not so basically computing power. And then POS, which means tagging, part of speech tagging or segregation or tagging. And then you tag it, then there will be a paradigm shift. Okay, part of speech tagging. What's Turing test? Turing test is a test where you where where you put machine and the chatbot and the interviewer. So the interviewer will ask the machine and the other person, and if he detect them, if the tester detect which is which, it will be a pass, a fail. But if he didn't, it is a pass. So a behavior of one distinguished from that human evaluated judge conversation with human and the Martian from the human. The Martian is said to have passed the psychiatrist Joseph Weizenbaum. I think in 1966. In 1966, what topic identification as an application in it's an objective thing. So, but okay, what are the main two texts? Okay, yeah, yes. Return. Let's go back. Until I remember things which I didn't before. Okay, let's go. Alright, let's go create out data vectorization. We're oh man, far behind. Oh Jesus. I do da, all the push up, push up, push up, push up. Me someone that you're gonna create. Help me, on the see you, baby, only you. Just wanna be, I just wanna be with you. Nobody else but you. I just wanna be, I just wanna be with you. Nobody else but you, Jesus. I just wanna be, I wanna be with you. I just wanna be, I just wanna be with you. Nobody else but you. I just wanna be, I just wanna be with you. Nobody else but you. Alright, so let's read, let's get it, let's get it, let's get it. Let's get it. Text summarization. Here was a method to automatically generate summarize advantages of the most another. this part. Okay, before this. Okay, text. Hello? Hello? እንመለስና ቀስ ብዬ ላንብብ። Okay, so what is text summarization? Okay, so deal with method automatically generate summaries of a given text, relevant and most relevant. So you put it like, for example, you have this a ton of text. Okay, now we can put it like this. Then this a ton of text right here, and just simple text. Summarization. All right. All right. You have a lot of data in summary algorithm for text summarization based on extractive techniques. Let's search for the algorithm. And until then, algorithms. This is crazy. No, it's the algorithm. There are algorithms like explicit, extractive, and abstractive techniques. Abstractive and extractive are difficult words, but there are examples. So, like extractive, Jesus, extractive. Oh damn, this is very weird. Extract. Oh, this is extractive. Extractive. And abstractive word. Abstractive. Oh, extract. Yeah, man. Abstractive means kind of illusionary. Oh, like abstractive. This is abstractive. It's abstractive. Extractive, by the way. I love this image. I love this image. Yes. I love this image. Abstractive and extractive. Okay, so alright. Extractive algorithm, extractive produce summary of the given text by most important word sequences. Uh, hmm, so, alright. So the extractor will like most words. Create summary. No, I think it's create summary. Create summary by extracting the words. Yeah, I guess this is it. Sorry, right. Abstract. Yes. Right. Here we go. All other sentence. So, cool. This is like that is the coolest thing you can do. Like, super. I think not text rank, but text rank to compare the sentences. Oh, bro, yes. Yeah. We have So this is it's it. There are two challenges for supervised extractive text annotation. The first one is it's necessary that the annotation contain the word that have to be in summary. When humans summarize text, they tend to do this in an abstractive way. Therefore, it is hard to find the training data in the required format. Necessary that the annotation contain in the words that to be summarized. And the second one is decision about the information should be included in the summary is subjective and depends on focus and the focus of task, while product description will be focused more on the technical aspect of text. Summary of the business value of product will put the emphasis on complete different aspects. So typical use of this text summarization is presenting a user a preview the content search result or articles. This makes it easier to quickly analyze huge amount of information. Moreover, in question answering, text summarization technique can be used to help a user find answers to certain question in a document. Yes, this will be the two challenges. I read it and try to imagine it. Doesn't matter how much text you put. Doesn't matter like for supervised learning, the first point is like it's personal, it's all about personal, so subjective and which ones you wanna do it. The second part is annotated text preferred to be in, yet may not. So this is so I'm gonna draw this. So personal thing, right? This is personal annotation. Alright, this is personal. Annotate. Let's go. Okay, Falcon. Right. So if Falcon have like Oh, we will play. We will see. All right. All right. So good. 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 Let's move to the next part in LP techniques. Alright, so 3.2 NL techniques. We're gonna start it off from the beginning, so let's stop here. Let's end it here, and we're gonna start part 2.